So the ability to transport Mars to orbit and beyond at scale is critical to the new space economy. And the success of SpaceX Starship IFT-10 has infused fresh blood into a lot of great ideas, not just for LEO and GEO, but also here on Earth. One such idea is the Starship Starport Global Network and the potential of transporting goods and people across the planet in minutes. I'm joined by Chris Smedley and Scott Walter. Chris is the CEO of Digital Habitats Corporation. Scott Walter is a mechanical and aerospace engineer and two-time founder of robotics companies. Welcome, gentlemen. It's great to have you both on Over the Horizon.
Thank you.
Good to be here, Royden. Good to meet you, Chris.
Likewise.
All right. So very briefly, your first reactions to the success of IFT-10, because without Starship, you can just say goodbye to a lot of these plans, including the Starport Network we're going to talk about today. Chris.
Yeah, well, I think a lot of us were pleased that the V2 ships stopped blowing up. That was a big issue. And I think that the progress made on the reorbital heat shield was impressive. And I'm looking forward to 11. And honestly, a lot of the ideas that we've been discussing will require V3 or maybe even V4. But it's great after the, let's say, a hiatus of bad events to finally have something in the win column.
Indeed. Scott?
Well, you know what my thoughts were, because we did a whole podcast about it. But basically, you know, the payload is data, and they got the data that they finally wanted that they weren't able to get in the previous 3 flights. So this time, it was great that they're able to get it. We could see that the progress is being made on the heat shields, on the deployment of the dummy links and everything else. A couple interesting events that shows sort of the robustness of the system. But yeah, it's a huge step forward, sigh of relief. That they're able to do it. And I think next year is going to be rather interesting that they have definitely a lot of goals, not just to go to orbit, but I understand even to do refueling tests now.
Yes, as Elon just posted a short while back. All right, so we're here today to talk about Starport. Chris, take us through this. This is a straight lift from your website where you talk about Journey to the Stars, Earth Starport Network. For those who may not be too familiar with this concept, why don't you please run us through what this is all about?
So the little video snippet that you'd shown in the introduction was a 2017 presentation TED Talk with Gwen Shotwell, who was at the time talking about what's called Earth to Earth. And then it turned into point to point. But the underlying concept was that you could travel anywhere on Earth in a matter of minutes. And that video shows some 30 different locations, and it shows generally you can get anywhere on the planet in under an hour. So this had intrigued me, and it gave me an opportunity to really go into it in depth and try and figure out what would be the technology needed. You see here, there's an example where people going to a boat, and then there's an offshore drone ship type of scenario. But, you know, we developed this concept over a couple of years and spoke with a number of global leaders at the time. And basically the interesting part about this is this market does 2 things. One, it's 10,000 times larger than orbital rockets. So, and secondarily, it basically does something that very few space programs directly do. It stimulates the Earth, the terrestrial economy, and savings here. So this is why we had such a great interest, because conceptually, you know, this video says we can now create or launch the aerospace industry. So a lot of Elon's original concepts for why you'd want to make the rocket reusable, we're saying, well, this is an aircraft. It's an aerospace craft, and we should treat it as such.
So there was the whole question at the time, I remember, because you had Virgin also try something, and the difference with Virgin was, I mean, it was trying to leverage existing infrastructure in terms of airports, correct? And then a Starport network will require a complete end-to-end building of infrastructure, at least for landings, and then you couldn't land the Starship anywhere close to a city or within a city. So it would have to be on the water, and then you'd have to transport goods and people back to shore. So it's pretty clear what happened to Virgin, but Starship, it seems to be doing a little better, I'd say, right, Scott? logistics are more a little more realistic, perhaps.
Yeah, I think definitely right now, if you remember, one of the problems with the Concorde is it was only allowed to fly over the ocean and not over land because of sonic booms. Now, with this concept, you don't have to worry about the sonic booms over land because you're going to be in orbit. However, when you deorbit and come down, there is going to be some sonic booms, which is why most cities would probably prefer to not be in the city center and to be offshore somewhere. So that potentially could limit the cities that you go to. They might have to be coastal or have some sort of water or something like that. That's one potential concern. Of course, the other is that, even airports aren't downtown for a reason. You want to have them a little bit away from the city center because you need that big area in case something goes wrong, and also a little bit for sound mitigation. So there will be definitely a new economy that grows up around that. Everything from making sure that it's a very smooth, because no one wants that last mile to be difficult. That, oh yeah, we got there in 45 minutes. Now it takes us 3 hours to get off of there into the city center. You're not saving me a whole lot of time. So again, they're gonna have to make sure that when you get off that thing, that you're really quick to whatever the destinations are going to be around that port.
If I can interject, one of the areas that I didn't mention earlier that Digital Habitats is very much involved in is the creation of aqua cities. So you may be familiar with seasteading, floating communities. And so we immediately looked at the oil industry, what they've learned about offshore rigs and all that kind of stuff. And, we've been working with Barca Ingalls. There's supposed to be a community starting in Busan in 2025. There were projects in various places around the world, including Maldives and French Polynesia. So when we looked at this particular technology, we said, well, you're actually going to and from an aqua city. And, to skip ahead to maybe a bit of the logistics, we said, you might as well have maritime law apply and have these be extensions to existing ports. So, for example, we looked at Los Angeles and all of the challenges of going shipping in there. And we actually set up the idea that you could have one or more starports near shore. And that additionally, these are mobile satellite ports. So this is something that you can't do with land-based products. And this means that you could basically put a number of them on the east and west coasts of the US and dynamically move all of your goods to a aqua city facility, and then have the large tankers only go to the offshore facility, and they would deload into smaller type vehicles to go, into the ports. So it's like an extension where it's the best of both shipping and port facilities. That's why it's called the Starport.
And that just made me think of something, Chris, is that this is going to open up maybe a different field of tourism, because, I'd love to see the Maldives, except to get from here to the Maldives takes like half my vacation.
Yeah.
It's literally half a world away. It's a long ways to go. There are lots of stops and everything else. And so if we have like, a week over Easter or something like that, say, oh, let's go to the Maldives. Like, sure. It's, whole trip is going to be getting there and back. So now suddenly that opens up these possibilities to visit parts of the world. And again, like the Maldives, it's literally in the middle of the ocean, right? So it's already set up to be able to have one of these aqua cities for landing on it. And then the other thing you point about, these ports can move around, because it maybe there's a certain season that everyone really does want to go to the Maldives. And then there's like a couple of, it's not so, but there's somewhere else, maybe French Polynesia. It's like, oh, you're just going to move them over there or somewhere in Australia. So that does bring up the idea that if you have a lot of infrastructure, it's going to be very expensive. But if for some reason it's only used 6 months of the year, how can I repurpose it? Well, that could be another potential way. So, it got me thinking that. And of course, what that means, it's going to be mainly for the people who can afford this at first, right? But even the people who can afford to fly first class, that's a long flight. That's, in your Wall Street broker, you can't take like 3 weeks off or something like that sometimes, especially in the middle of the spring.
Yeah, well, maybe I'll just add that we do a lot of work with island communities and innovation, obviously, this concept of, and so, not just the Maldives, we were invited by the Maldives government. We did a formal proposal to them on on the Starport and some of the key folks that were involved. And the reason why it collapsed is that Sri Lanka's economy evaporated. So, that was the connection there. But our key contact was from Dubai, and he was thrilled with the idea it would be 20 minutes to go from Maldives to Dubai. And so in the same context, we were talking to people in Dubai as one of those forward-thinking cities, places like Singapore. Others like that are more interested in this kind of technology. But, to kind of get to the crux of it, the opportunity I see is not passengers, because that's going to, just like self-driving cars, take a little bit of time. It's literally speaking with the existing port managers and offering them a turnkey solution that would let them move cargo in air containers. So, we were in Turkey, we were in Bulgaria just before the Ukraine war, discussing with the Bulgarian government, how do you move NATO assets in and out of the Black Sea, right? So that's where there's a bit of the touch of the military, but the people that were in Burgas, the airports there, invited me to do presentations on this concept because they said, wow, it's like an extension to air travel. It's aerospace travel. And, the ability to prove it with, let's say not even high value cargo, just heavy cargo that needs to be expedited quickly, and that, people are willing to pay a premium that would put FedEx out of business kind of model. I think that's the first opportunity for us to commercialize this. And then, if your rocket blows up or there's a mishap or there's operational issues, it's teething pains for this aerospace industry.
As we've seen in the past with so many cutting edge technologies, military applications and use for cargo transport, etc., tend to be the first use cases. I reserve the right to ask the dumb questions. And I do that on behalf of my audience who are really inquisitive and not necessarily always from a technical background. And this is one of the questions I found really interesting from one of our recent chats, Scott. And that was, how on earth do humans survive re-entry in the Starship as it is now?
Not a big problem. So for the Apollo astronauts, they had to deal about 7 Gs, I think, going up, maybe even more coming down. So on the reentry, I think it was like 11 Gs. The shuttle was designed to make sure that you never exceeded 3 Gs on the way up or the way down. And looking at the Starship coming back in, it's coming in a gentle glide slope. And I think it only got up to about like 2.2 Gs when they were showing what the maximum. So that's nothing. I mean, carnival rides are worse than that. So the shuttle was literally designed that your grandmother could go to orbit and come back. Whereas, the Apollo spacecraft, no. I mean, you were going to have blackout. There was a reason why they had to lay down and everything else. And that's the other thing, is that when you re-enter, you do want to be in a recumbent position. You don't want to be sitting up, just because it makes sure the blood flow is all right. And again, if you're coming in at 2 Gs, it's not going to be a whole lot. I'm not sure what the ride was up, but I think it was also not exceeding like 2 or 3 Gs on the way up, and they would be able to do that. But I got a couple of questions about that, but I'll bring that up later on with Chris.
Yeah. Now, the reason I ask you that is because if you're talking about human transport with the Starport network, you need comfort. If you want to go to the Maldives or Dubai, any other, or French Polynesia or the Azores, you'd rather travel in comfort.
Yeah, well, I mean, it's over in 45 minutes. The reason why you want to travel in comfort is that when you're trying to go across the world, it's like LA to Sydney. Is that like a 19-hour? I'm not even sure there's a direct, it's like really, really long flights that you're talking about here. I've done those flights to Japan from Detroit, and they're like 14-hour flights, and that's uncomfortable. And that's why people pay the premium for business class.
Well,
but
all you have to do is
can
just
deal 45 minutes in
Qatar Airways.
Yeah, I mean, you really don't need that much comfort. You don't want to be uncomfortable, okay? But
right.
You don't need to sleep. I mean, the problem with it is that you're going to be getting to Shanghai. You're going to be leaving at 3 p.m, right, from New York, and you're going to be arriving at 3 a.m. in Shanghai. And so it's like, man, couldn't they take a little bit longer so we sort of arrive when the city is waking up?
And on that point, like when Scott was talking about 2.2 or 2.4 Gs, I remember being at Disneyland where they literally had the shuttle ride as a simulator. And my wife was like, oh, no, I can't do it. And I'm sitting there doing 2.4 Gs going, da, 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 da. I'm having fun. So, you know, there is a certain, let's say, fitness or adventure seeking person that will go, this is what I'm going for. And they actually want to pay for those 2.4 Gs. And then the second component is when we go offshore, and this is something that, you know, I wanted to mention, our position is not to use boats like you saw in the Starship video, but to look at eVTOLs and to do something like what Uber Elevate did so that it becomes a high-end rich experience. And then you've got a facility there that, you know, would be akin to what an airport would. So all of the amenities, getting people prepped, so on and so forth. And then to circle back to Scott's point about 20 minutes and the conversations that I've had with SpaceX, they're like, there will be no bathrooms. You know, there will be no stewardesses. There will be no flight services. It's strap in and it'll be over so fast. Just, you know, here's a video to watch. Yeah, exactly. And I think people will pay for that, you know.
Yeah. I mean, people are again saying, you know, what I pay to do one of these orbital things with Dragons. I was like, no, I'm just going to wait a few years and be a passenger to one of these things. And I'll finally get, you know, the experience when I have of being able to go up there. And it'll be quite a thrill. No doubt about it.
And, you know, even if Musk meets, let's say, business class air prices compared to Richard Branson's, you know, $250,000 on Virgin Galactic. Correct. As soon as I see Starship getting any sort of traction, Virgin Galactic is so dead. It's crazy dead. You know,
yeah, I thought it already was dead.
And also New Shepard. I mean, why would you do New Shepard for 5 minutes of weightlessness? You don't even go anywhere. And it's $250,000. And this might be, maybe it's $25,000, maybe even $100,000, but the experience is going to be much richer.
Yeah, especially with the overview effect and all that kind of stuff, right? That's what people are paying for. Partial weightlessness, you know, it'll just be amazing.
Correct. And, you know, Chris, it's really interesting you talked about eVTOLs in Dubai, because we've just had, I think, Arch Aviation and Joby conduct trials for their eVTOL aircraft here in Dubai. So it's like a perfect use case, Dubai. And anyway, the Middle East countries are amongst the first to try out, or they're more future ready than most other parts of the world. So, well, it's going to be interesting.
So, you know, I see a future where you have the Tesla vehicle, you know, as part of travel and tourism. That's your taxi ride. It takes you to an eVTOL that takes you to the offshore facility, and then reverse on the other end, all in about an hour and a half.
Yeah, like a RoboVan or something like that that's going to be moving around. But I agree. When you pay that much money, that last mile experience has to be good. So probably like these eVTOLs that will take you from there directly to your destination. I don't want to have to then go from there into the city center and then find a cab or something like that. It's like, no, get me right to it. So I imagine that would be pretty easy to do.
And when you look at a place like Maldives, they have more aircraft than many nations, right? And that's the way they get to everywhere. All of these island locations are very aircraft specific. So that seems like a natural fit.
Absolutely. All right. So, Chris, I believe you have a deck of slides for us. Let me just load that up, and please do take us through this.
Okay. So this is basically the cover sheet here that talks about what we're looking at doing is accelerating humanity's transition to a spacefaring race while transforming terrestrial transportation. Sorry about that, tongue-tied. It's kind of interesting. We just finished Master Part 4 at Tesla, and I'm literally using the same language to point that, you know, it's sort of a corollary of Elon's vision. He's saying to make us a multi-planetary. My assertion is I want to make us spacefaring, and that we need to be able to do that by having terrestrial technology in terms of rockets and all the other things. So just the video that's here, I'm not going to play it, but I invite people to go take a look online. It's where Gwen Shotwell says in 30 minutes you can go anywhere on the planet. And this was a TED Talk, and she was speculating that it would happen in 10 years, which would make it 2027. So the timing is not that far off. So this is the first main slide that we can kind of go into. So my first assertion was that the suborbital market, especially cargo, when you look at transforming shipping and airlines, is vastly larger than anything that could be imagined. That he wants to get 1 million tons to Mars. I mean, there's billions of tons floating around on the planet every day. So it's also a proving grounds, the suborbital, in terms of logistics and all that kinds of things. So what we're hoping to do with the Starport network is to literally end aircraft and to supplement a large majority of shipping. And we believe that we have some ways of doing that. And of course, the key is that you have a decentralized point-to-point transport system that can deliver things with high precision and high velocity. And, you know, to tie into Elon's concept of delete things, what we've said is rockets circumvent the need for all terrestrial infrastructure. So this is a key element in terms of what extra stuff do I need? The only stuff that you need is the launch and landing facilities, the starports, the support infrastructure, tankers, and that can be deployed on a local basis. There's no connection tube or anything else that you might need. So there's basically a couple of different areas that I think we can go into here. The first one is this idea of rocket cargo an hour. And I'm going to kind of just skip through this because it's a fairly straightforward concept. This is where the cargo becomes most relevant. So this is something that I call the rocket time dilation effect. It's sort of a play on bullet time from the Matrix. But it points out that the Starship was maybe 150 tons was their payload capacity in this configuration. And that's about the same capacity as an A380 cargo plane. And yet, because of the difference in speed, you can get 15 times more cargo per day, at least, by using a rocket over an A380. And so this doesn't really factor in a lot of the delays at the airport, the wait time, the fueling times, all those kinds of things. And it could be potentially much more. So, you know, this concept comes out something like this when you look at the chart, where when you're about 3,000 kilometers in distance, the rockets move roughly 10 times faster than conventional aircraft. But as you move higher and higher until you get to orbit, the net differences go to 33 times or more. Now, the next slide is basically saying this is the same conversation, but with ships, where you potentially are looking at moving 1,000 times more payload, not in total, of course, but per vehicle unit of time, per day kind of thing.
Yeah.
Right?
Yeah. Mm-hmm.
So the next slide is a bit tongue-in-cheek because it talks about needing infrastructure. It's also potentially up to 20 times faster than a Hyperloop. So, you know, I was part of many of the Hyperloop groups in the early days, and it requires you to physically build something. So, you know, that's why I see it honestly being a stillborn technology that was like a solution in search of a problem. And there's no reason if you would have a rocket fly over that same location. And of course, Hyperloops and things that are ground-based are operating in one dimension, whereas we're operating in 3.
Yeah.
Right.
Yeah.
Right.
Yeah.
So
Yeah. They're very fixed. You cannot easily say, oh, I meant it to go over there. You have to build another loop or move that around. This way you can reconfigure. It's like the difference between having a subway system and a bus. The bus network, you can rearrange your timetable any way you want, your routes any way you want. But with the subways, you're stuck with what's in the ground and that's it. And if you want to change it, you have to go through a major construction project. But I have one question there for you, Chris. You said, I think the payload is 150 tons, is that right?
That was the you know, to round it for the sake of simplicity with the A380 conversation, we said if you're suborbital, it's 150 tons. But when you
okay, that's what I was wondering, whether it was suborbital or orbit, because I seem to remember that aren't they targeting something like 150 to orbit, or is that 150 expendable? Because I would assume that you know your suborbital payload will be like way higher,
right?
Or not, because I guess the thing I kind of forgot about is sometimes it's actually harder to bring stuff down from space than to bring it up. So evidently the cost of going up to orbit is pretty high, But if you manufacture something up there, the cost to bring it down is even more than it was on the way up. So I'm wondering with the suborbital flights is that you do have to remember you are trying to land a Starship now that's heavy. It's not lighter. So it may be that you gain some on one side of the equation, you lose a little bit on the other.
Correct.
Okay.
Correct.
So there's 2 points that I want to make, Scott, and that is, ask me later about the new Starhopper, a specific suborbital Starship.
Yeah. Yeah.
So that would arguably be something that is configured for heavy loads, right?
Yep.
But I'll sort of skip into a different concept that I'm sure you'll appreciate. On this screen now is something that I said suborbital starflights leverage the rocket equation. Instead of being captured to it, it's an opportunity to actually have it work to our advantage. And so for orbital launches, the goal is maximum payload with a specific delta V, right?
Mm-hmm.
So every ounce is critical. However, for suborbital launches, the delta V is only the distance, right? That's all that it is. So what happens is that you ultimately have the best leverage of the rocket equation on short distances, light payloads, and big rockets in terms of thrust capacity and ability to move to minimize gravity losses. So you can see in this chart, there's an area that's outlined in red where you don't put a lot of cargo in. And this also happens to map out to the reality that almost all terrestrial, payloads are under 50 tons, under 30 tons, even when you're aggregating. And if you're looking at having multiple destinations, you probably want to send the rocket up with even one particular payor, one particular vendor. You don't need to aggregate the solutions. And that way you use a minimal amount of fuel. So I'll sort of move ahead to the next slide that just really illustrates how you go out at distance. Here's effectively your velocity. And then, Scott will appreciate this. This is also going to be your heat flux considerations.
Yeah.
Right. And your ability to do propulsive landings with basically just using the mains instead of header tanks, because you just put a little extra fuel in order to handle heavier loads. Right. So that concept is something that I think most people in space nomenclature, they're so fixated on the rocket equation keeping us tied to the Earth that they don't realize that if you've already got a rocket with the capacity like Starship and you just put a little gas in it, you can probably take 10 tons around the world with, almost zero expense and be fully reusable like you would with an aircraft.
Yeah. Yeah. And I think if you go back to that slide, it shows a really interesting thing and how it flattens out at the top. So there's going to be a break-even point. That one there. Okay. So it's going to be a break-even point where at some point, the cost of sending cargo, let's say from Boston to Los Angeles, equals whatever is like the competitive terrestrial forms of being able to do that. So let's say that they're equal at that point. Well, that means it's game over when it's Boston to Tokyo or anywhere else, because the additional cost to go from LA to Tokyo is like nothing. Whereas with standard transportation, it's linear per mile. If you double the distance, you double the cost. And of course, you double the time and everything else. Whereas in this case, it's just like you say, the curve gets really flat. So it'd be really expensive. The idea of doing this probably from like Boston to New York doesn't make sense because the distances are short enough. But at some point, there's going to be that sweet spot that it takes over. The other thing I'm wondering is whether the configuration of the hopper will be much wider, because as you know, the reason why the Falcon 9 is so pencil thin is because it has to deal with being able to be transported across the country on roads, bridges and roads and everything else. And that usually means the same thing with cargo, is that a lot of cargo has to be able to fit underneath our bridges and everything else. So if you have something that's huge, you have to take it apart and put it in little pieces if you want to ship it a long distance, unless you put it straight on a freighter and then maybe it can do it. It can be a little bit bigger. This opens up the possibility, especially if they make these things really, really big, that now you can ship cargo kind of like already together in one piece. You don't have to disassemble it for the rail roads, because remember, it was like supposedly the Roman chariot, which has determined the size of the Falcon 9, literally. If you go all the way back to the wheels and everything else, it's like that was the size, 2 horses, determine that. And so now that opens the possibility that you can change things volumetrically. You can also get stuff there really quickly. And I'm wondering, is that they are showing these things being a 2-stage rocket, but I really think that if you strip down just the Starship itself, you could almost use it as a single stage to orbit vehicle. The thing is, you would have like almost zero payload. It would be its own payload. But since we're not trying to go to orbit, it may be that, suborbital, you would be able to do it, and whatever booster you have would be different. And since you're not trying to go into orbit, the configuration of the Starship, especially if you have a booster underneath it, doesn't need those 6 engines. All it needs is whatever it needs to land, which, again, you're right, Chris, there are no header tanks at this point. It might be it's completely reconfigured that it just has a much smaller tank, because the only time you're lighting that thing up is when you're coming down. You may not need it on the way up. It may be that the booster is able to give you enough. But the configuration would probably be very, very different for point to point in the size of the tanks and everything else. And again, like your header tank won't be in the header anymore. It'll be down the tail.
So I see your enthusiasm, and I love it because I was hoping for this. So let me sort of take a little aside and talk about what we were doing with the Starhopper. First question was, why do we not have more engines for suborbital, i.e. 33 engines, and the Starhopper is ostensibly a booster? And then the next part is there is a standard payload section, and it's like aircraft do, that air containers would be put in because they're light, not shipping containers, they're way too heavy, but that it would be fairly simple for SpaceX to design the payload base similar to what the shuttle was, with an open door, and you just slide it all in and arrange it the same exact way as aircraft have been doing for decades. So leverage that infrastructure and whatever the ground operations are. But when you came to the analysis of the numbers, we did something where we said, let's assume that you have a booster with a nose cone and a payload section, which arguably, in a small second stage of some sort. And that may be because you may want to move it elsewhere, but conceptually that's a single stage rocket. And, we found you could actually get about 5 to 10 tons SSTO. Right. And this is just a math game that you play. And that's why we were looking at the V3 and the more powerful Raptors and so on and so forth. You're muted.
Yeah, that's the orbit you're talking about. 10 tons to orbit built that way. And if we're not talking about orbit, suborbital, that would be a lot more.
Right. But then the other aspect that's really kind of interesting, and I'll show this in a bit, is you could do it as a 2-stage and use the existing booster, at which point a nearly fully payloaded Starship with a heavy payload, 500 tons or whatever, could go on the destination, because it's the booster that gives them sufficient velocity. And then the booster's doing the boost back to the main station. So this is something where I see it being, the boosters being actually the workhorse of the suborbital systems. And, that would indicate they will also have much better use for the orbital stuff as well. And we should be building more instead of what is currently being discussed.
So we'd only have Taylor tanks then instead of header tanks, because the booster doesn't really have to, or let's say the booster does all the work. The Starship doesn't have to do anything except land. Exactly.
So, if you look at that previous chart that I had, I wonder if I can bring it back up. But it basically, let's assume that for the sake of discussion, it was 5,000 kilometers for 4,000 kilometers per hour, right? Or 4 kilometers per second. So that's what the booster's already releasing the ship at, right? And this is all still gravity turns, nothing's changing there. But then you have an independent vehicle that can use its own fuel, change locations. I mean, to the earlier point, we were talking about being stuck on tracks with subways and the like, is if you had a number of starports for both emergency and other reasons, you can go downrange, you can navigate anywhere you want to an array of different destinations, right? You kind of multiple drops, that kind of thing. So this is where we'd actually built a whole Google Maps that showed different starports from the distance, from orbit, and the idea would be you're in your Starship and you steer it basically to where you want to land, more than what we're doing now with our existing logistics.
Now have you looked into retrograde suborbital paths? So normally we always want to shoot east. So if we're in New York and we want to go to London, we're going over the Atlantic that way. And that's the natural way that we want to go. If we are going the opposite direction, suddenly this gets interesting. London to New York is the best way going to be going over the Atlantic, or actually, going in the traditional route over Europe, over the Pacific, over the US, and coming down. And obviously that's going to be a lot longer path. I don't know that there's going to be that much energy advantage to going in that particular direction. But the thing that's kind of scary is the idea of going in a retrograde path against the flow of how all the other are going around, and whether that's been addressed. So I'm assuming retrograde is the only way a lot of this makes sense. But I'm just wondering if there's any reason for one or not to it. Yeah.
It's not even retrograde. It's literally point to point.
Yeah.
So Miami to Toronto, right? That's going to be, and all the differences is, rotational advantage. So this is conventionally with orbitals. That's exactly what you're looking for near the equator, right?
You won't have the orbital tailwind anymore. That's what's going to happen, right?
That's all it is. You will not have the rotational tailwind, right?
Yes. Yep.
Which means it's more like a ballistic trajectory for artillery shells, that kind of thing. It's a Haverson equation, but at the same point, it's literally just point and shoot kind of model, right? So it's far easier to figure out the logistics of that and calculate where you want to go. Now, I'm going to bring up another concept here. And this is something that we had developed a while ago. And this was the concept of rocket pipelines. So now you have an existing Starship, and you say, listen, depending on how far we want it to move, we will fill up the tanks with all kinds of methane, including potentially payload as methane, right? And then we can move that LNG ostensibly to anywhere in the world in a very short order. And it's just a matter of underloading the locks, right? Or conversely, you can add more locks and detank the whole stack. And what this is, bizarrely enough, is the ability to move those two particular chemicals in cryogenic format anywhere in the world rapidly as a form of transport. So given, what we've had with Russia and concerns about global LNG supply and the length of time it takes tankers to get from A to B, this is something that, and I'll bring up the next slide, being a Canadian, and I was talking to the Canadian government about this is literally Edmonton and Calgary being able to do Starhopper-based LNG services to deliver their product to North America. So that concept, and if you look at the fact that I think half of the ships are currently carrying petroleum or oil-based products in some form, and they usually take 3 weeks to get anywhere, this might be a way to strategically, and here, yes, there's a military element, there's a space element, but there's also the idea of moving energy in its liquid format at incredibly high speeds. And here's another interesting plus, is if it's fast enough, you're moving cold as well.
Mm-hmm. Yeah.
Right? The cryogenics are moving from one side to the other.
Okay, so I'm assuming it would go back empty. So we have a full one. It's going there. We're offloading then a lot of that LNG, but we're leaving just enough to get home.
Well, or to get to the nearest starport.
Okay.
Right? So if you're gonna land at a starport, you could be presumably refilled. Right?
Oh, you could be refilled, but I thought the whole point of bringing the methane there was to be used locally and not to be using it for the Starship. So if I'm saying it's like, for some reason we have really cold weather in one part of the States and there's no natural gas there, we got to get it over there in a hurry. We're going to send them over. We're going to detank as much as possible. But we got to leave enough for that Starhopper to be able to make it back to get the next load to come back. But when you're returning, you're basically returning empty. So you won't need quite as much to make the return journey. So I'm assuming that when you go through that whole process, that you actually have a net positive of movement of LNG from here over to there, and you're not just using it for the sake of going back home.
But that's also something that the individual flight can manage, especially if there's specific payload tanks. Because with the payload tanks, it's not restricted to just LOX or methane. You could put ammonia, you could put any sort of product that you'd want to put in there. And, one of my pet favorites that, will also address the refilling problem is move water, fresh water, right? Potable water. Many of these island communities have it shipped in.
Oh, yeah.
Right. And so, this is a bit of an aside, but one of my pet projects is to build a massive water facility in orbit and then extract the oxygen and the hydrogen on space rather than having cryo-LOX. So, Starship's looking at refueling up there. If we were to literally just send out a bunch of water, it's much easier. There's no cryogenic issues. And ultimately, it's the same water that's going to need to end up in Mars or in human habitation or, so we did.
That's smart because that gets rid of the boil-off problem right there. The problem with cryogenics. And if you have enough, you've got plenty of power in space. So like you say, okay, when we just generate it on demand.
Right. You just do a water station. We did an analysis where we said, if you took 150-meter sphere of water at 4C, that it would take about 7,000 Starship flights. And that would serve 1 million people without recycling for 2 years.
Okay, but if we're looking just as the fuel sample, because one of the reasons why hydrogen is not necessarily the best rocket propellant is because its volumetric energy density is horrible. So when you look at the shuttle or any others that use hydrogen, it's almost like 7/8 of the thing is hydrogen because we can't compress it down that small. However, and the same with oxygen and these other kinds, but when you mix them together, suddenly the same amount of hydrogen shows up in a much smaller volume. Obviously way more dense, but that means the size of your ship gets smaller to be able to transport the same amount of hydrogen atoms and oxygen atoms versus if they were both cryo to begin with. That's a great idea, Chris. It really is.
Great. And maybe we can talk more about it later because I'd love to see that get in front of Elon to go, why are you doing this with the Starship? Build a base. And then I'll add one more element to it, which is ammonia. It's a refrigerant. It's a heavy hydrogen carrier, and ultimately we have, I think, 7 different chemicals that are what we call, biochemicals. They're what life is made of, and they're going to be part of every orbital facility. And so the idea was ultimately to make a gas station where water was the largest potential issue, and you indirectly get LOX out of that.
Yeah. And so that's the whole thing is that nature tried figuring out how to use hydrogen for a fuel and it couldn't. So it just combined it with carbon. And that's basically how you liquefy hydrogen. You stick it into another molecule and that's it.
And so, there are also massive ammonia pipelines on the planet, right? Yeah. So there's all kinds of water pipelines. So this seems like a natural extension to basically say, just put that in the payload of the rocket.
Yeah.
And move it accordingly.
Correct. Yeah. And that's the other thing, the efficiency is that if we need to make hydrogen, the amount of electricity we need to do it on Earth is really high because solar panels are not as efficient. But you put them on orbit and then suddenly it's much easier to generate the electricity.
And even when you're putting them in orbit, you can use direct heat from sun rather than
from the sun as well. Everything. Exactly.
Just break it that way.
You could probably use dissociation. Exactly. You heat it up and it just breaks apart. So that infrastructure would be a lot easier and would not be as cost prohibitive. And at the end of the day, we're looking at the amount of that material that you can get in orbit to be useful as a propellant. And that to me sounds like the most useful way of doing it.
And if
solidify it.
if I go a little further, I'll bring up something that Bezos mentioned a while ago, which is why don't we move emitting energy production, nat gas plants into space?
Yeah.
And literally vent to orbit.
Yeah.
Right. So why have it be terrestrial? Yes, there'll be solar in there, but this is the whole idea of you have an industrial facility. In our case, we're also looking at this on aqua cities and, you know, take it out of the deep communities and put it into a place. And what better place than to do it in space and have that entire chemical plant be sitting there for rocket use, for human habitation, and for the core of building long-term space habitats. Sorry, Roden, I went a little far out into the cosmos there.
Don't mind me. I'm having the
but
time
Scott
of my
seems
life.
excited.
No, it's a great idea. I mean, I've always thought about these things around some of the edges, and you finally like put that together. It's like, yeah, just ship the water up there.
We should get Casey onto these chats.
Well, maybe this is why I'm open to have more conversations. I don't know what your time are on these, but these are the kinds of ideas that I think once the Starship gets going, you know, and we can build this terrestrial infrastructure with the starports, and the original idea was that we would have SpaceX certify them once it figures out what we're trying to do. And, you know, just to slide on to the starports itself, originally we took inspiration from the fact that they bought 2 old oil rigs and renamed them Deimos and Phobos. And Elon had put out some renders about what that would look like. And they ended up selling them, and everybody went, oh, Starport's dead. And Gwen said, no, we just sold an asset. But when you look at oil rigs, they have some really unique features. First of all, they use semi-submersible technology, which is incredibly stable in high winds. They're offset from the water, less issues with flame trenches. They come with integrated methane facilities and equipment, all that kind of stuff. And if we could basically just do a tower on it and plumb it. So, you know, we'd said, let's say you could do that for $100 million all in. You know, you get a rig from whoever. Then the idea that we were proposing was that each community and its space program would say, well, we're going to commission to have our own starport for our own national traffic, for our own national space agency, and we'd have SpaceX be able to certify it. And then the military angle was that we get the US military to certify it for military operations, and that it's used as airports are today as forward bases, which would also be mobile forward bases. Yeah. So the logistics of that was another aspect that I think we should consider.
For those watching, what Chris is talking about is the Rocket Cargo Vanguard program of the Department of Air Force, United States Department of Air Force there. Chris, I just wanted to ask you this question and just help break down the numbers. Since you talk about cargo and transport of mass cargo point to point across the earth. So the cheapest form of transport is essentially by water, right? And so you have these bulk carriers that have evolved over time. What does this potentially do to all of that infrastructure in terms of numbers?
Well, I think the numbers to focus on is, and the parallel I was drawing was, digital communications shrunk the planet to a point because we could move at the speed of light. Using rockets to move cargo takes things that take weeks and are tied up on logistics everywhere. I only have to remind people of what was happening with the Evergreen and the Suez Canal and
the Houthis in the Red Sea
and everything that's going on in terms of global geopolitics. And remind people that the Port of Los Angeles, ships coming in often take 3 weeks to be able to unload their cargo, and they have port-side problems. A lot of this comes because there's an existing infrastructure that moves everything through an aggregation point, you know, in shipping. And that's historically how it's been. But if you were to have highly distributed starports, it basically moves almost all transportation into a 10 to 15 minute conversation. So even from a manufacturing perspective, It's like Tesla's driving off the line, driving themselves directly to the customer. No need for infrastructure, or and I see massive amounts of GDP savings in going that route, independent of the cost of physically moving the freight. Does that make sense?
Yeah, and there's no more that hub and spoke. That's the other very important thing, is that's what kind of broke a lot of airports. So they just got too big. And that, in order to go to any major place, you had to go through New York and you had to go through Heathrow to get to anywhere else. And then finally everyone said, well, why don't we have like a direct flight to the smaller cities directly rather than having to go through? And that made transportation a lot easier. And that's the same with the internet, is you don't realize that there is kind of a hub and spoke. There's so many hubs in the internet. It's almost like there's nothing that's, like you say, there's nothing that's an aggregation point that ends up being a chokehold on all that. Now, one other interesting point in history that we're kind of circling back here, the original Redstone rocket, the launch tower for it was an oil rig. So you're kind of coming back there. And the other thing, my understanding, I think SpaceX may have sold those rigs because they learned a lot from it. They realized it would actually be easier to build one from scratch than to try to retrofit the thing.
I wouldn't know, right?
Yeah.
I mean, they've got some great engineers there, as we've seen. But the thing that I notice is that a new oil rig is like $1 billion.
Yeah.
And the second component is that because of the vagaries of the oil industry, at any given day, you can literally buy thousands of them in the Gulf, right? And so even if it's a question, and this was also something where I thought it would make the most sense to commission it at local shipyards. So, local industry, government gets to go, oh, great, there's a project here, just like regular shipbuilding. And then eventually what I'd suggest that SpaceX should do is to build something like they've done at Starbase in larger shipping centers around the world. And because fortunately, since they made it out of steel, there is an entire industry that could build all kinds of really radical spacecraft going from the cruise ship industry, right? All of that can be now retrofitted with partners, and it doesn't have to be SpaceX to do the heavy lifting. But to come back to the idea of the rigs themselves, if you can get it for cheap, and some of these things are less than $10 million, and we'd said if SpaceX would give us a quote, let's say $45 to $90 million, there's a $100 million budget. Now, we would want them to commission this and test it out and have their engineers figure out, what's it actually going to cost. It certainly shouldn't cost what Boca Chica cost, because that's where all the R&D is done. That's why we want to, and you see how quickly they're bringing up the towers in Florida. So presumably they've gotten that almost down to a science now, and it might be a good time to go back to them and go, what if you just slap that tower on top of an oil rig, just strip it to the bones? What would be the costs? And I don't have the connections, but I'm sure you guys do. So, I'm going to skip away from the presentation that was there and show you, this is our Starport map. And the green lines are 1,000 kilometers and 10 flight minutes. So I'll let that sink in when you go into, you zoom into places like, Santa Monica, San Diego, Las Vegas, San Francisco. We're talking about a 7-hour drive from here to here. That's going to be 5 minutes of flight time. So that earlier conversation that we were having about the ease of logistics of being able to just put in a few locations that are under 1,000 kilometers apart and then substantially move a lot of trucking or rail or other products by rocket is a way, I think, of immediately commercializing that.
And that wouldn't even need a booster. That could probably
exactly.
just be, yeah.
That would be a single ship.
Yeah, I think it's like barely suborbital.
And if you commission, a standard Starship and say, well, like they did in the early days of aircraft, it's letter mail, it's something that is just give me something that I can move, be insured, and try this out. And you charge the premium for speed of delivery, then that's a way of introducing, like they did back in those days, the startup of that kind of industry and giving it a leg up without being fixated on what is the maximum payload that could be moved from point A to point B. So you only need a fraction of the rocket's capabilities, And, you know, I think what it really does would be to retest the reusability, and
Yeah.
it's low stress on heat shields. You might not even need substantial heat shields.
That's going to say you may not even need the heat shield for something like that. The stainless steel may be enough.
Right. But, you know, on that earlier chart, when you're getting to 3 or 4 kilometers per second, that's around, you know, that's actually, and maybe I'll also illustrate with this diagram, coast to coast across the US, 20 minutes at roughly 3 kilometers per second. So it's SR-71 kinds of speeds, right? In terms of average speed. So that's the kind of trip that 90% of the actual, you know, cargo is moved throughout the United States. And at those speeds, they're similar to what the boosters are facing when they're doing reentry. So, you know, you're on,
and there's no heat shield. There's no heat shield on the booster.
Right. But you're on the, I would probably suggest SpaceX will tell us, well, why don't we just build all of the Starships with a heat shield? Because that weighs X tons.
Yeah.
And it doesn't matter in suborbital. And more to the point, the presence of the heat shield protects the ship.
Yeah. You know? Yeah. Or you could use a different kind of tiling that might actually be more reusable and easier to use. And
less maintenance,
and it is pretty heavy. I mean, the thing is, again, we get the tyranny of the rocket equation. If we're able to take 50 tons, because those heat tiles, they have a lot of mass. You take that thing off, and suddenly, wow, we can jam more cargo in there.
Right, but that's certainly almost gets to the point where an individual, you know, starport operator would have different vehicles from different companies. I mean, this isn't just once you establish the starport, Neutron could come in with smaller payloads, different configurations, you know, and they all use the same underlying infrastructure and arguably the catch system and propellants and all that kind of stuff. So it's a very generic rocket solution, especially once you go suborbital. There's just far less restrictions, and it's like almost like a home rocket club on steroids.
Right. And you kind of make it sure that they all use the same avgas, in this case, methane, because I think Neutron is methane, but New Glenn is hydrogen, and that requires a different infrastructure. And you know, hydrogen is just so hard to use. It's so explosive that I think a lot of the starports would say, you want to work here with us, it's got to be methane.
Sure, but either way, I mean, you can support hydrogen rockets as a secondary fuel, as we previously discussed. You know, that would be on a individual rocket maker saying, you know, first methane for the reasons that you mentioned. Just because you're starting with Starship, let's get that one working perfectly, and then see if there's a real demand for anyone else. My suspicion is that this will become so dominant that it'll give a place for all of these Starships to go and, you know, really ramp up. Elon wants to do 150, keeps talking about them going to Mars. And I'm like, one of the other slides that I had says that apparently by 2030, there's an expectation of something like 31,000 aircraft, commercial aircraft, so on and so forth. And so if you want to prove reusability of an aero spacecraft, why not set in the factory to crank out a bunch of these things?
And then give them a couple of test flights.
Yeah.
Because think about it. It's like you've got a window of every 2 years, right? That means I've got a Starship sitting there for 2 years waiting to go. You know, the one that just came off the assembly line. And that's stranded capital. I can do something useful with it in the meantime. It's like, oh yeah, just do some point-to-point stuff. We verified the structural is really good. Everything is going well. Okay, now it's ready to go. Because no one, I mean, as much as you'd like to go to Mars on the shiny new Starship, at the same time, you want to say, did the thing have a shakedown cruise yet? I'd like to know. Yeah,
well, that's a really good point, is that, you know, whatever, I don't know what you think the Starship will cost. You know, let's assume it's $25 million. Mm-hmm. Then if you could say, you know, it's going to last 100 flights on Earth and get that down to, you know, a very low capex, that rocket is making tons and tons of money, just like a Tesla will when it's self-driving.
Yep.
Right. And it doesn't matter at the end of the day if it never gets off planet, or if at some point, an individual commissions and says, well, now I want it to go to Mars.
Yeah.
And this also ties into
at some point there's an end of life. There's like, at some point these ships are going to have that one last trip, and it's like, well, okay, that's perfect. At this point, we don't care about it coming back because we've got all the useful life, and we know we really can't get anything more out of it. That's it. So
and then you get full recyclability if it's a suborbital too. You just melt it down and build another one.
Yeah.
So, you know, it's a very good environmental way of doing it. And it's not dependent on anything elsewhere. And that goes back to my original point, which is throughout the history of space exploration, everyone goes, what's in it for the people on Earth? How do you solve our earthly problems? And this is why I think that this network is so helpful in that concept.
All right. So I have a question here, Chris. So the Starport network mostly considers coastal cities, but can this not be adapted to land? And
Sure.
I want to play this out. So we've seen this in China. These are autonomous trucks that have been deployed at mines. So you have a lot of problems that are automatically taken care of. Starship could very easily do this. And so how have you considered perhaps Starship being deployed for this use case, and how does it compare versus, let's say, the Tesla Semi, and in a chain configuration? How would that compare?
Well, you know, as you can see from this diagram, we start with the assumption of coastal or lakes. So in the case of Toronto, we've actually mapped out a starport that is literally in the geographic center of servicing 20 million people. And that addresses the fact that you can't have both high population and land and have it close to the people, right? As we discussed originally. So, you know, even right here, doing a few of them throughout the Great Lakes, it's the same thing, as it doesn't have to be coastal. That's just usually where most international large-scale shipping is. But there are also locations like here where maybe there's not a very large lake, or, you know, it's a river or whatever. And, you know, we've got ones, you know, I can go out to Azerbaijan and Iran and other places, right, where there's literally a location that would be mapped out in the middle of the desert, right, where the noise abatement isn't an issue, but by using eVTOL aircraft, it basically allows you to build exactly what they've built at Boca Chica. Make sense?
Yeah. So, I mean, there's no reason why it has to be on the coast. It's really just noise abatement. It's going to be really tricky. I mean, there's a lot of places inside the US that are uninhabited that you could land, but the problem is they're uninhabited. No one wants to go there. So if you want to go to Kansas City, you know, it's going to be pretty hard to find an area that you could say is far enough away that that's not going to be an issue.
Right.
Yeah. You ideally want to have it, you know, be within 50 kilometers of a heavy cargo hub, more than even a people hub, right? To make that work. But that's where I think, you know, the way that I'd phrase it is water adjacent works best. And that ties into aquacities and floating. And you know, one of the other things that I kind of wanted to bring up that is interesting is the CARICOM Starport Network. As somebody who spent a lot of time there, you'll see, oh, look, one in Panama, one in Nicaragua, right? And all of these happen to have, you know, as you get closer to the equator, you've got that orbital velocity that's kicking in. And we even have here one in Puerto Rico. So rather than, you know, going just to Florida, the question is, why doesn't the US establish one in Puerto Rico, right? And get the velocity. So this whole area here, every one of those communities could say, not only could we use it for all of our Caribbean-based cargo movement, people movement, travel and tourism, but every one of those locations is now got its own orbital facility to be able to launch, and they're all movable, right? So this becomes an entire network that would be seasonally deployable, very much like cruise ships are. Same thing, and of course, you know, when you look at the GCC, right, and the locations that are there, it's all highly mobile. Scott's thought? Or thought, Scott?
No, that makes sense. I mean, the biggest problem with going down the equator in many cases when people are trying to go off on an island is just that there isn't any infrastructure there. That's the reason why Elon wanted to be in Boca Chica, is to get as close to the equator as possible and still be in the continental United States and have a big body of water facing to the east. But then he's finding out, it's like, my goodness, there's no infrastructure down there. They had to build it all. And so, there's no roads. They had to bring in electricity. They finally, for a while, they were actually running generators during the construction because they couldn't get enough electricity in there. They finally got that in. And so you think, well, there's Brownsville, there's a little bit of infrastructure there, but having driven there, it's a long ways just to get from Brownsville, like to Houston or to San Antonio or anywhere else. I mean, Texas is really, really big, and you begin to realize how remote it is. So it's very hard to get the people down there to get all the infrastructure that you need. That's why things work out a little bit better in Florida, is like everyone wants to be over there. You've got schools, you've got universities, you already have all of this industry and everything. And it's actually, for a lot of SpaceX engineers, it's quite a sacrifice to live in Boca Chica. I know that it's taking a toll on a lot of them being so remote. It's like, you got to be like a frontiersman who just doesn't care that's where you want to be. But at some point, it does make sense that you're going to be in these more thickly settled areas to be able to get it. And, I think the ESA, they've kind of learned how difficult it is to operate so far away in French Guiana, because they want to be down by the equator, and they're literally in the jungle. And they build the satellites in Europe, and then you got to get them over there. And then, transporting satellites a long distance, you want to make sure they're hermetically sealed and you don't get moisture and corrosion effects from salt water and everything. So that creates a lot of challenges sometimes where those hubs are. But as this infrastructure starts to build out, then a lot of that probably starts to go away, because, now you have the local talent. You're starting to have that infrastructure coming in that makes it accommodating. But it's going to be hard at first.
Or I'll give you a flip side on that. And I'll point out that humans are land fixated, and everything you've described is land based. And as I said originally, if you look at these facilities as cruise ships, right, that, they have all the infrastructure with them, and they get to move to where it is that the action happens, right? Then the infrastructure becomes part and parcel of the facility that you're offering, and it's just a standard quanta that you need to do in every place. And just, as a little further extension, when you look at, the Gulf of Mexico, I actually looked at all of the underlying pipelines. Did you know that Boca Chica has a methane pipeline within 5 kilometers of its location?
Oh, I can believe that. Sure.
And that I've literally posted, Elon, why don't you just tap that and have it come, right? And so in the same context, we're looking at, if you have a starport, then, you've got drill ships, you've got all of that infrastructure, methane tankers, it's already floating on the water, easy to rent, large amounts of volume. And that would be an easier way than trucking it from wherever like they do now.
Mm-hmm. Yeah. Again, that's the roads get torn up because of all those trucks they have to bring in the methane. It'd be a lot easier. I know eventually they want to do the production locally, but why they haven't tapped in or figured out a way to do that, that's kind of a mystery.
Yeah. Like why don't they bring a methane tanker in?
Yeah, I guess they just don't have the port to offload it. Maybe I'm not sure how deep that channel is there. I know there's some stuff that kind of goes in and out of there.
But there are smaller tankers, and if you look at this, like even their current drone ships that they use for Falcon, you don't need to get into the big rigs. There's jackup rigs. There's all kinds of stuff in that area and expertise. You just challenge them and say, listen, if I'm going to have 100 Starships running out of the base, I'm going to need this much propellant, both LOX and methane. How are you guys going to get it to me by sea? And maybe out of that comes, we need to buy ourselves or build ourselves a floating port.
Oh yeah, they should. I mean, that's how a lot of tankers are offloaded anyway. They don't actually come into port. There's something several miles out. They basically connect to a pipe, and so why not just make a short pipeline, a couple of miles off, and just park the ship out there, and you're done.
Exactly. Exactly.
It wouldn't be that hard to do.
And the same thing goes for water, for deluge and for the city. And, they're trucking it in right now, as you know. That's, I think, another project for SpaceX to look at.
Mm-hmm. Yeah, they're going to have to definitely come up with a pipeline for the water or something like that. That is absolutely crazy. They have to truck in the water.
But everywhere else in the world does that every day, right? Many places truck in water or ship in water. Yeah. So it's sort of a solved issue. It's just a question of building the shore side.
I'm just wondering at what scale this will be cheaper than things like reverse osmosis, in situ reverse osmosis.
Way cheaper. Because it's done everywhere in the world today, everywhere in the world, right? People, like most of the Caribbean is they get their water by truck or by tanker. And so, as you mentioned originally,
too, for sure.
Ships, ships move liquids in particular at very low cost.
Yep.
And if they're not time sensitive, then that's been historically a very effective way of moving that kind of stuff.
And this doesn't have to be potable water for the deluge system. Right. So even then they could use anything. You just have to make sure it's not corrosive water, no salt in it, and they're fine. And that meets whatever the EPA standards would be to make sure that considered polluting our wetlands with water.
It's really more a question of securing your supply chain. Just like Tesla has to do with its vehicles, I'm suggesting they're going to need to secure all kinds of supply chain for both the starports and for the shore facilities.
Mm-hmm. Yeah, it just boggles the mind what this does for supply chain security. Especially given the current geopolitical situation.
Especially, now that you mention it, when you have the U.S., and I totally agree with this policy personally, going, we want to reshore manufacturing. And then if you had something like this to go, and there's my delivery system, it just totally disrupts the supply chain, as it should.
Mm-hmm.
Wow. It's been, I just got taken to school. Thank you so much. And I loved it. Thoroughly, absolutely loved it.
I learned quite a few things. Thank you, Chris. Yeah.
You're very welcome. Hopefully we can do something with it more than just a session. I'd love to see if we could bring it to life. It's been sitting in the shelf. And when I saw your earlier podcast talking about Starlink with the other fellows, I was like, okay, it's time to speak up, because this may be the perfect moment to get it going.
Mm-hmm. Absolutely. And I'm so grateful that you did that and you reached out. It's been such an experience talking to you and Scott together on this. Unfortunately, I have to wrap this up now because we're well over our deadline, as Scott keeps ribbing me. we start off aiming for 30-minute chats, but then we have so much fun that it crosses the hour mark. But thank you so much, Chris.
Mm-hmm.
Pleasure talking to you, and Scott, as always, thank you.
Same here. Yep.
Likewise.